This is screencast number 4. We're on page 350, and we're going to talk about the contributions of scientists and the gradual development of plate tectonic theory. All right. So many scientists contributed to the development of the theory of plate tectonics. The research and observations that contributed to the theory have had a great impact on scientific thought. On this page and the next, fill in each numbered activity with information about its impact. Okay. So let's just go through the little tidbits that they gave us. First of all, this was a map drawn in 1858 by Antonio Snider Pellegrini, showing how he thought that the continents had fit together at one point. This is Alexander von Humboldt, who found identical rock layers in Africa and South America. Okay. It says over here, early observations. For hundreds of years, scientists and explorers noticed that continents had similar coastlines. For example, these observations were made by Abraham Ortelius in 1596 and by the naturalist and explorer Alexander von Humboldt in 1800. Okay. Alfred Wegener and others noticed that different continents had matching landforms. The map on the left shows similar mountain ranges of the same age and composition. What that means is this part of the coast of Africa, this part of the coast of North America, not only have the same landforms, but they're made of the same types of rock. Okay, and then this area matches up also. Okay, this is one example of evidence that Wegener used to develop continental drift. Okay, then we go over here. Lovely little picture of Alfred Wegener in his fedora and his coat. And it says, developing a hypothesis. The research of many scientists helped shape the hypothesis of continental drift. Some examples are described on the previous page, which we just looked at. In 1912, after piecing together all the evidence, Wegener presented continental drift. It was an unpopular idea in the scientific community, but scientists continued gathering clues to try and explain Earth's features and processes. Okay. In the mid-1900s, Harry Hess and Robert Dietz researched sea floor spreading. Drummond Matthews and Frederick Vine studied magnetic patterns on sea floor rocks. Evidence from these and other studies, including the exploration of mid-ocean ridges, led to a refinement of continental drift. Drawing on evidence from around 400 years of research, the theory of plate tectonics took shape. Okay, so we've got a photograph over here. In 1975, the deep sea research vessel Alvin took scientists to a mid-ocean ridge to observe volcanic activity. And the photo down here says this photo shows volcanic gases bubbling up from a mid-ocean ridge. All right, so let's tackle the questions that they gave us now. So we've sort of gone through the evidence and who contributed what, and now we're going to answer the questions. How did the information shown in the map above affect scientific thought about the movement of continents? Well, since there were matching rock formations on different continents, scientists began to think that the continents had somehow been joined in the past. It is evidence and logical reasoning which causes scientists to propose new theories or modify old ones. So they saw something and they began looking for an explanation as to why they made the observation that they did. Why were they observing that? Okay, then number 12 is over here. Describe how research about seafloor spreading changed scientific thought about continental drift. Many who were skeptical about continental drift accepted the notion of continental drift when we had additional evidence from the seafloor, the magnetic reversal patterns and the ages of the rocks and things like that. Okay. Number 13, summarize the historical development of the theory of plate tectonics on the lines below. And I sort of did it as a math equation. We had matching coastlines plus matching geologic features plus matching fossils equaling Wegener's theory of continental drift. So he took all those things and used them to propose continental drift. But then we take continental drift and add evidence for how the continents moved, the seafloor spreading, the magnetic reversals, the patterns of volcanoes and earthquakes and things like that. And that led to plate tectonic theory. So plate tectonic theory is a more thorough explanation of how things are happening. All right, now we're going to go to page 352. By the way, if you didn't get a chance to write all that down, obviously pause the screencast and get it written down before you move on anymore. All right, but if you're ready to move on, I'm on page 352. How does research related to plate tectonics affect society? Well, it affects society quite a bit. Knowledge about plate tectonics has had a great impact on society. For example, it allows scientists to identify areas of risk for earthquakes and volcanic eruptions. And because of that, it helps people prepare for those events. Building in high-risk areas may be constructed to withstand or minimize damage from these natural disasters. So knowledge about plate tectonics, earthquakes, volcanoes associated with them will help us to figure out what sort of buildings we need to build in what locations. Using knowledge of plate tectonics, scientists are also able to locate valuable resources such as minerals and fossil fuels. Okay. Certain resources are known to exist near plate boundaries. Some resources, for example, are common in areas near seafloor features called black smokers. That's what you've got a picture of up here, and it looks like it's just black smoke pouring out of the seafloor. Black smokers form along mid-ocean ridges where plates spread apart. This produces magma, and the surrounding seawater therefore has a higher temperature and the minerals are dissolved. And as the warmer water rises and cools, the minerals solidify and drop out. Okay, so we've just talked about this, so you should be able to answer this question number 14 on your own. Let's go on to the last page in this one. How does research related to plate tectonics affect science? The theory of plate tectonics has had a great impact on scientific thought because it has unified many fields of earth science. Unified meaning like bring together many fields of earth science. For example, plate tectonics helps scientists understand topics such as different fossil distribution and the pattern of earthquakes that we find. Plate tectonics also helps scientists understand how Earth's surface has changed in the past and how it will continue to change. So not only what it's doing today, but what we may have in the future. Knowledge of plate tectonics allows scientists to explain the formation of certain land features, such as the Himalayan mountains, the Atlantic Ocean basin, things like that. Plate tectonics also helps scientists understand many Earth processes, including earthquakes and volcanoes. An understanding of plate movement helps scientists understand why certain climate changes have taken place during Earth's past. Research about plate tectonic continues today, and ongoing research will continue even more, will contribute even more to science and society. Okay, so again, number 16, you should be able to look back through the reading and identify some ways that research about plate tectonics has contributed to science.